Good morning, ladies and gentlemen. All right, we are solving radical equations today. You have class practice 14, and we only want to do the front today. We're going to finish it on Monday. All right, so keep that in mind. You are not going to turn it in. Yeah. You are not going to turn it in. You're going to hold on to it, but I want to see that you get it done before you leave. It's the 24th. Thanks. Sorry. Thank you. All right. Okay. All right. Thank you. Okay. Here we go. First of all, ladies and gentlemen, we are solving radical equations today, and yesterday we were using rational exponents. What does x to the 1/2 power really mean? Square root. Very good. So it's really a root with the power of 2 in the index there. And so what would 2 to the 3/5 really mean? Just as a review here, what do these rational exponents really mean? Power over index. I like that. So the index is 5 and the power is 3. Okay, so power over index. So we're pretty much doing the same thing as we did yesterday. And so this idea here, if I have x to the 1/2 power, how can I get rid of the power? Reciprocal, yeah. So you can use a reciprocal power, which would be 2 over 1, which is just 2. And 1/2 times 2 gives me 2 over 2, which cancels out to be 1. So we just get x to the 1st equals 5 squared, which is 25. So reciprocal powers are very cool. And in fact, we like them a lot better than clumsy radicals. Okay, we can do a lot more in exponent form. And so that's the idea today, is going between radical equations. So you're going to see radicals, and we actually would rather work with exponents. Okay, so here we have example 1. Solve the equation. Check for extraneous solutions. Solve the equation, check for extraneous solutions. It is absolutely essential that you check for extraneous solutions. Extraneous means it's mathematically we're going to get an answer. Mathematically it'll work, but when you actually check it, it doesn't. And it usually has something to do with powers of 2 or roots of 2 when we have a negative number. Even powers or even roots with negatives cause all kinds of issues, okay? So it's something to pay attention to anytime we have even powers or roots and negative numbers. We want to be very, very careful. Weird things happen. If it's odd powers and roots, those work fine. But anytime there's an even power or root involved, it's weird. So here, this is what we would call a radical equation because it has a radical in it. And you can see the radical. This is a 4th root or 4th radical. And I'm going to say that anytime you see those radicals, let's just change them to exponents, because it's just a lot nicer and neater looking, all right? So I'm going to rewrite this as 5 minus x to what power? Is it to the 4th or is it to the 1/4? 1/4. Yeah, there's a power here of 1. So this would be x to the 1/4 power. You'll notice I put parentheses. We want to make sure that we're very, very clear what is inside the radical. So we want that same power here just on whatever's inside the radical. Okay? Is equal to 0. We want to solve for x. What do we need to do first before we can do that? Subtract 5. We want to get rid of anything that isn't trapped. What do you suppose I mean by trapped? Inside the parentheses, it would be trapped, okay? So if it's outside of the parentheses, we want to get rid of those things. So we have a negative. Quantity x to the 1/4 equals -5. So what else do we need to get rid of? The negative, and you can think about it like a -1 times this whole thing. So we want to divide by -1. Again, it's not trapped. Get rid of it. So we have x to the 1/4. Negative divided by negative is +5. Now, what do we need to do? Reciprocal power. Yeah, get rid of, flip your power. So we would say reciprocal power. So 4/1 is really just 4. 1/4 times 4 is 1. So we get x equals, what is 5 to the 4th? 625. 625. All right. You do want to check your answers. So on your calculators, to check, really checking is going to be the difference for A's and B's in this class this semester. In my calculator, I can do 5 subtract, and all of your calculators have a 4th root. If you have Casio here, so I'm going to do 5 subtract, and TIs, you can do the same thing, 5 subtract. I want to find my 4th root, because I really want to use the original function if I can. The Casios have a little 4th root. Right here, it's a second shift function, so it's yellow, mine is yellow, so I'm going to use shift, and then that I'm going to put in the 4 so that the calculator knows what my index is. So that's going to tell it, the 4th root there. What is my x value? 625. Yeah, 625. So I'm going to put that in parentheses so that the calculator knows 4th root of 625. And I put that in parentheses. If you have a TI, you can see that it equals 0 when I pressed enter, so that's good. If you have a TI, your root button is under the math menu. So in the TI, 5 subtract. I'm going to do the 4th again for the 4th root. Is under the math menu. So you go to math right here. And then you can see that you have the xth root. And your calculator just will fix that right up for you. Of 625. And you can see that 625 is completely under the radical. Kind of nice when you have pretty print. And that works too. It is really important that you guys learn how to use your calculators. Practice, practice, practice. All right. Letter B. We want to get rid of anything that's not trapped. By not trapped, I'm going to ask you, what is this power affecting? It's just affecting the x right now. So there's little invisible parentheses that's saying that 4/3 is only affecting the x. Everything else we need to get rid of. What do you want to get rid of first? The negative, yeah, we are going to add 3 first. There's a lot of chatter going on, guys. Please stop. I don't want to have to repeat myself when you start working. 240 plus 3 is 243. All right, again, we want to, what else is not trapped? The 3. So how do I get rid of that 3? Divide by 3. Divide by 3. So I have x to the 4/3 equals 81. 3 goes into 24 8 times. 3 goes into 3 1 time. All right, now what should I do? Reciprocal power, which would be 3/4. Again, make sure you're being very careful here with parentheses. The notation is on purpose. If you always write in the parentheses to the power and type it in your calculator, it'll work out right. Most of you. Some of you have older calculators that have programming errors. So we get x equals, what do we have to remember with 81 to the 3/4? Plus or minus, very good. This is an even index. So we need to remember plus or minus. So we're immediately going to put our plus or minus there. And then in our calculator, we can actually type in 81 caret 3 divided by 4. 81 caret 3 divided by 4. And we get 27 with a plus or minus in front. Again, I'm going to check this very carefully. I'm going to take and plug in my x there. I'm going to plug in the 27. So to check this, I would do 3 quantity 27 to the 4/3 power and then subtract 3. So I'm going to type in that whole thing and see if it works back into the original. 3 quantity 27 to the 4 divided by 3 power and then subtract 3. And I do get 240, so I know it works. I also need to check negative 27. So again, you need to be very careful with your parentheses. If you don't do the parentheses right, then it's not gonna work out like it should. So making sure that negative 27 is in parentheses, caret 4/3, and then subtract 3. And again, if your calculator isn't doing the right thing, we want to figure out why. Okay? All right. Questions on either of those? All right, last two here. We have the square root of 6x minus 5. And then adding 10 equals 3. Again, radicals are clumsy. What number is in the index here? 2, little 2. So I want to be clear. Everything that's inside the radical, I'm going to use parentheses to show everything that's inside the radical. And I'm going to rewrite it with a power. What power can I use? 1/2. Yeah, the power is 1. The index is 2. So we can change it so it looks just like yesterday's stuff. And then we have our plus 10 equals 3. All right. Now, what is not trapped? What's something we can move away? The 10. Yeah, we're going to subtract 10. Not trapped. You're going to move it. 3 minus 10 is negative 7. Now, what should we do? Reciprocal power, very good. So that's 2/1, reciprocal power, or just 2. Powers cancel out, leaving me now with 6x minus 5. And you'll notice I don't need the parentheses anymore because we got rid of the powers. So those parentheses aren't necessary. What is negative 7 times negative 7? Positive 49. Again with the parentheses, here's why that's so important. If you didn't write parentheses and just type in negative 7 squared, what's the answer? Negative 49. When we use parentheses and square it, we get positive 49. You have to tell your calculator the right way, and the parentheses are the correct way, okay? Here, the 2 is just repeating the 7. So it's negative 7 times 7, where this is saying negative 7 times negative 7. Repeat both things 2 times, okay? So parentheses are so important. We have not yet solved for x, so what should we do to solve for x? Add the 5. So I have 6x equals 54, and then divide by 6. So we get x equals 9. All right. Again, you need to check your answers. So I'm going to take 9, and we're going to drop it in place of the x. So I'm going to use my square root button with parentheses for everything in that radical. And then plus 10, and I want to see what it equals. All right, so I'm going to use my square root button. Quantity 6 times 9 minus the 5, and all of that, you can see I put parentheses for everything that should be under the radical. And then plus 10. And it's supposed to equal 3, but does it? Yeah, it equals 17, not 3. All right, wrong answer.
What?
Yeah.
How would you do that?
This is an example of an extraneous solution. All right, it's not the correct answer, not what we were anticipating. It does not check. All right, this is the beauty. You have to check your answers. All right, so this is actually no solution. All right, it doesn't actually work. The math seemed to. Again, anytime you have an even power or even root with a negative number, caution. Negative number, we squared it, problems abound. Okay, so anytime you're seeing negatives and even powers or roots, you need to be very, 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 very careful. All right. All right, so that is why you need to check your answers. All right, last one here. The quantity 2x plus 5 to the 1/2 power minus 4 equals 0. What should we do first? Add 4. I almost got that. 2x plus 5, thanks, sir, to the 1/2 equals positive 4. Now what? Reciprocal power, very good. So that's really raising it to a power of 2. 1/2 times 2 cancels out, leaving 2x plus 5 equals what? 16. And now how do we isolate x? Subtract 5. So I have 2x equals 11, and then divide by 2. You will get fractional answers. 11 over 2 is a great answer. You could also divide it and get 5.5. If your decimal stops, then you can use the decimal. It's exactly equivalent. If you have a decimal like 5 divided by 3, this decimal goes on and on and on forever. If you have a decimal that goes on forever, the fraction is best. All right? But if your decimal is 11 over 2 and it's a decimal that just stops, you can see 5.5. You can just use 5.5. It's an exact answer. It's perfect. Okay. Decimals that go on forever, fractions are best. We do want to check this answer. So again, I'm going to go back and just plug in my 5.5 in place of my x to the 1/2 power and subtract 4, and I want to see what that equals. I'm going to use the TI for this one. So I have 2 quantity 5.5 plus the 5, close the parentheses, to the 1/2 power. Now I'm up here in pretty print, it's in the superscript. If you arrow over, then it'll drop back down so I can subtract 4. And I get 0, and that's what we want. So we know that that answer works. Okay. All right, do you have questions for me? The rule of thumb is check. Okay, check your answers. All right, you guys have class practice 14.